Hello everyone, Teacher Jonas here, and today we're going to learn a new science topic and it's super fun. So, let's review what we learned last class, which was action at a distance, forces. So let's review this topic. Something happening is called an action. Like me, moving my arm, moving my hands around, clapping. These are all called action. Now, when action happens at a distance, it means that there is no contact. You see, my hand has no contact now. Boop. Now it has contact. No contact, contact. So, this boy has contact with the box. But now, no contact. So we call it at a distance, right? So, forces that we know of are push and pull. But as you can see, both of them need contact. You have to touch the box to push it. You have to touch the box or a rope to pull it. These are two forces that need contact. They are not forces of at a distance, okay? So they are forces of contact. Now, look at here. With force, you can do many things. You can, I don't know, change the way it is. For example, something is moving this way, boom, now it goes up. Or my hand is still and I move it down. It's something you can do with force. Or my hand is like this and then now it's like this because I use force. Or let's see, I don't have rubber, but you can stretch a rubber and make it longer. So these are effects of forces. Forces can do these things. Now let's see. Action at a distance forces. Let's see what's happening in this picture. The apple is falling from the tree onto earth, right? So it's falling down. But as you can see, there is no one pulling or pushing or something, doing something to the apple. So this is called action at a distance or non-contact forces. So we have three of them: magnetic, electrostatic, gravitational. So let's see. We start with gravitational force. Now this one is called gravitational force. Earth has very strong gravitational force, which is why whenever you drop something, boop, it goes down because of Earth's gravitational force is so strong. It pulls, not really pull, it attracts everything down towards Earth. So, for example, when you hold a basketball or a tennis ball, when you let it go, because of Earth's gravitational force, it goes down. But gravitational force, guys, is so important. Guys, gravitational force is super important because of Earth's gravitational force. Moon orbits around Earth. It means Moon will not go away. It just goes around Earth. So, if Earth had no gravitational force, the Moon would just float away into space. Oh, that's not good. But what about our solar system? See, this is the sun. Because of sun's gravitational force, all the planets orbit around the sun. Now, if sun had no gravitational force, all these planets would just float into space. We don't want that to happen. So, gravitational force is the force of attraction. Force of attraction. So, look at here. If you want to do an experiment to see gravitational force, you can do this. As I told you, you can stick some clippers or it's like a light object with a piece of thread to a stick like this and hold it steady, hold it straight. You will see that they're all facing down. But even if you tilt it like this, you will see that they're still facing down because they're getting attracted by Earth's gravitational force towards Earth. Haha, cool, right? Now, let's talk about the next force, which is called electrostatic. Electrostatic force. Electrostatic is very cool. Look at this man's hair. When you rub a balloon on your hair, it starts to attract. It starts to pull your hair with it. That is electrostatic force. Or here are some other examples. Comb, the comb that you comb your hair or comb your hair with it, attracts pieces of paper. Why? Because of electrostatic force. Guys, lightning striking Earth is also electrostatic force because clouds keep rubbing on each other and it creates electrostatic force and it hits Earth. It's pretty scary, right? So this is electrostatic force. And last class I showed you how when I rub a piece of plastic on my hair, it sticks to my hand. That is because of electrostatic force. Okay, so let's see the next force, magnetic force. Magnetic force is also very fun. This is called a magnet. A magnet attracts, it pulls other metals or other magnets. Now guys, it's not always the same. Magnets attract the opposite side. For example, some magnets have north and south like this, different color. Now if it's north, it will get attracted to south. But if it's north and north or south, it will repel. It's like it's gonna push. For example, look at here. These are two magnets. Now, this is south, this is north. See, it attracts, but north and north. See, wait, let me show you. It will not stick. If I let it go, look what happens. Ding. Oh, it fell on the ground because it repels it. It's like it pushes it away. So that is magnetic force. So this is all we learned for today. Gravitational, electrostatic, and magnetic. But this is just a review. So let's get to the real lesson. Before we do that, let's do a little practice. What type of force is this? Boom. This is gravitational force. Yes. Now, what type of force is this? Remember this. This is magnetic force. Right. Good job. What about this? This is electrostatic force. Great job. Now, today's topic is about magnetic. 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 Great job. So, today's topic is about magnetic. Now, magnets can be super strong. Guys, this is not magnetic, okay? This is magnet. Magnet. Magnet is this. This is called magnet. Magnets can be super strong. They can even be small and super strong. Look at these two. They're as small as an apple, but look how strong they are. They make the apple fly away. They can just be weak as well, like the magnets that we put on our fridge or our toys. I love these toys. They are very cool magnets. Okay guys, now I have some questions for you. Which one of these will be attracted to a magnet? So imagine you have a magnet. Which one of these will get attracted to the magnet? Number one, a magnet. Yes, a magnet will get attracted to a magnet like this. Number two, a needle point. Yes, a needle point is usually made of metal. Number three, a clip. Yes, clips are made of metal too, so they get attracted to a magnet. Number four, some plant. Now, plants will not get attracted to magnets. Number 5, a dog. No. Number 6, some flower. No. Number 7, what is that? Oh, it's more magnets. Yes, magnets also attract magnets, right? If it's the opposite side. Number 8, screw. What about these screws? Yes, they will get attracted to a magnet. Number 9, oh, a thread needle. Yes, it will also get attracted because it's made of metal. Number 10, chips. No. 11, paper. No. 12, wood. No. So now we know that these items will get attracted to magnets. Very good. Now, some metals are attracted to magnets. These are metals. Look at here. Brass, tin, titanium, steel, lead, copper. These are all called metal. Now, this is, for example, fabric. This is wood. These are different materials. But the material that mostly gets attracted to magnets is metal. But again, not all metals. These metals, such as nickel, for example, a nickel knife, will get attracted to magnets. Or a cobalt coin. A coin made of cobalt will also get attracted to a magnet. Or a spoon made of steel. Steel is a type of metal. It will also get attracted to a magnet. Iron nail. Now an iron nail will also get attracted to magnet. Steel paperclip. Oh, it's also a steel, just like the spoon. So it will also get attracted. Now, as I said, some metals. We call these things that get attracted to magnets magnetic. Magnetic. So, some metals are attracted to magnets. We call them magnetic. So, for example, let's see. This coin. See? It gets attracted to the magnet because the coin is magnetic. The coin is magnetic. Very good. Okay, let's see more. Spoon, scissor, even a key are magnetic if they're made of some metal. Now, non-magnetic things are, for example, books, pencil, or these items. Now, these items are not made of metal, right? Now, guys, not all metals are magnetic. For example, we have magnetic metals and non-magnetic metals. Not magnetic, yeah. For example, iron is magnetic, but aluminum is not magnetic. Nickel is magnetic, but copper is not magnetic. Cobalt, which is used for screws and some stuff like that, is magnetic, but lead is not magnetic. Steel is magnetic, but brass is not magnetic. So as you can see, not all metals are magnetic. Some of them, such as iron, nickel, cobalt, and steel, are magnetic. Now, to remember, just remember CINS. CINS. When you see C, remember cobalt. This is how cobalt looks, and we make it into this. I is iron. This is iron. We make it into this, like a hammer. N is nickel. Nickel is like this. We turn it into like a coin, like this one. S is steel, like this. We turn it into this. So, CINS, cobalt, iron, nickel, and steel. CINS. Remember that. Okay, everyone. Now, As I told you, not all metals are magnetic. So now I have some coins that I want to see which ones are made of magnetic metal and which ones are made of non-magnetic metal. So first we have satang, the smallest one, right? So let me show you. I have one 25 satang and two 50 satang. Look at here. Do you see them? Now, as you can see, the colors are different because this one is made of aluminum and these two are made of steel. Let's see. Oh, steel is magnetic. But what about aluminum? No, aluminum is not magnetic. So that's it for satang. Now what about 1 baht? Now 1 baht it used to be made of nickel, but now is made of steel. But as you remember, CINS, nickel and steel are both magnetic. So let's see, 1 baht. Yes, it's magnetic. Now 2 baht. It used to be made from aluminum, but now it's made from steel or nickel. So this one is made of, let me see which one it is. Oh, so this is the new one. You see, it's made of steel and nickel. But what about this other 2 baht, this yellow one? Uh-oh, it's not magnetic because it is made of aluminum, and aluminum is not magnetic. Now next is 5 baht. 5 baht is made from copper. Now let's see if copper is magnetic. Nope, it's not because copper is not magnetic, right? Now let's see 10 baht. This is a 10 baht coin. It's made from copper and aluminum. No, because copper and aluminum are not magnetic. As you remember, CINS. So, which is cobalt, I is iron, N is nickel, and S is steel. These are magnetic metals. Okay guys, so now you know about magnetic and not magnetic. And that's it for today's class. I hope you learned something new. Now, until next time, Teacher Jonas out. Bye bye everyone. See you.